Good evening, Professor. Today I'm here to explain you about my assignment 4. In the assignment 4, we were given 4 questions, and in the first question, we had to perform principal component analysis on the pictures folder given to us, and we also had to resize it into 128 into 128 pixels, and also to obtain 12 eigenvalue pictures after PCA being performed on them. So to perform PCA, I followed the commands given in the lab, and these are the commands which I used in MATLAB to perform PCA. And unlike the lab, there was a difference in reading the image files from the folder because there was a difference in the sequence of images and kind of images. So there was a difference in reading those files. So in order to read those files, we converted them into the folder into a data folder into data in the form of matrix, and image functions are performed on those matrix. So these are the commands instructions I used in order to read the data and then perform PCA. And then these are the instructions which were given in order to plot eigenplaces. You can see here I have used a for loop of for 1 is to for the length 1 is to 12 for the 12 images which we need to obtain, and I use a subplot function. As we know, subplot function is to initiate a matrix with the number of columns and also specifying the position of each element. So I have used these particular commands in order to plot those eigenvalues, and I also used a test image in order to perform a sample PCA on a test image for one only on one particular image. So these are the instructions which I used in order to perform PCA on one particular test image. So these were the result which I obtained after performing that, and these were the final output after performing PCA, and the 12 eigenfaces which were obtained after performing the PCA in the first question. For the first question, and for the second task, we were to perform k-mean clustering and to obtain a 64 into 64 size image, and we had to group the images into 7 clusters. So in order to perform clustering, we basically the used instruction was idx c k means is equal to data k means data of this 1 is to 100. Here the idx is which is connecting and the images into particular groups. So IDX is basically for indexing, and here the K is given as 7. So we had to divide into 7 because we had to divide into 7 individual groups. So these are the instructions which I used in order to cluster them. So as you can see, firstly I've started with a loop for 7 clusters, and those clusters again in turn, each image was getting into each cluster. And for concatenating those images, I have used string concatenate function here, as you can see it, and then image operations are performed on those particular pictures. This is how I clustered each picture and into group them among 7 groups. And this is a function I used to display the average faces of the images. So again, this is the image 8, which will obtain only the average faces of each image of the images all overall we have. So that was the instructions, and this is the output I obtained after performing the task after clustering them. Here you can see 7 groups of pictures obtained, and all the images are grouped into 7 different categories. And this is the eighth picture, which is the average of all the images. This is the output of that. And here ends the second question. And by moving on to the third question, in the third question, the difference is only we also have to perform PCA on the clustered images, and to reduce the dimensions to 100 dimensions. The main purpose of PCA, to reduce the dimensions and perform obtain higher efficiency in the processing of the images. So in the third question, we also performed PCA and also clustered into 7 individual groups. So these are the as similar to the first question. Second question, we also clustered the different. I also clustered the images into different groups, similar to the second question, and then the outputs obtained were these. I just specified it individually so that it would be clear. These are the outputs, and similarly to that, we obtain a eighth image in which average of all images are also obtained. And the difference is we have performed a PCA function on those things, as you can see here. That is the difference between the second question and third question. You can see the distance and is a square root of Euclidean distance. So this is the PCA function of performed. And then the fourth question was to compare the results of solution 2 and 3. So basically the PC application onto the images has various benefits. It removes noise and gives better results compared to only clustering the images. So that was a difference which I obtained, and basically PCA is used to data reduction and interpretation. So it obtains condenses the information contained in a large number of original variables into smaller set of new composite dimension with a minimum loss of information. As I've written here, the basic agenda is to decrease the dimensions of the image and to obtain better results and better efficiency when you compare it with the clustered image, just only clustering it. So when it is of higher dimensions, we'll have much usage of PCA. This was the comparison of between solution 2 and 3, and challenges. The basic challenges which I faced in this was to read the images initially, and then to figure out how to group each picture into different clusters. That was the basic challenges which I faced in both the questions and second and third questions, and I could figure it out finally, and I would like to show you the outputs obtained. I could have run this commands programs before, but then again for individually I have to run each time, so it's one and the same. It's taking a lot of time. So this is the output of the first question, as I have shown you in the presentation, and this was the program which I've used for first question. And if we go to solution 2, here as you can see, the image is being read in a similar way, but a different method, because we have used string concatenation here in order to combine it with some particular some particular thing which is common in the pictures. So, and we have clustered the images, and I would run it before so that it will take time and I can explain you in meanwhile. So the clusters are being formed, and you can see in the command window that all the images of the first cluster are being displayed. Each cluster are being displayed. So it usually takes a lot of time because it is 932 pictures in the cluster in the folder. So it is usually taking a lot of time, and you can see in the workspace also that the matrix being formed are of 932 into 932, which is 16,384. So if this is a data which is being, as I've told you, that we are creating an array after reading the file of image face underscore images. So the data is of this big value, 16,384 into 932. which is the size of the matrix, and these are the matrices which are formed for each individual thing which we are assigning them. Like for file name, we have for file names we have given here. For file names, the nine according to that the matrix would be formed here. So that which can see in the workspace, and as in the command window, we can still see the display of different clusters and pictures, picture numbers. So that is because we have given here a display cluster command, and the size would be from 1:2 length of the clusters, as we know that, and it would be grouped accordingly. Here, the string concatenation is being used so that we can form an array on basis of the origin of the org, which is here, like org, the images, the image folder, and the file name. On basis of that, it can form an array, and we can see the output finally. So this is a figure 1, and this is figure 8, and this is figure 2, and figure 3, figure 4, figure 5, figure 6, and 7, 8, as you can see here. So this is the output of the second question. So the third question, I would run it immediately. And as I've already explained that the third question, the difference is performing principal component analysis also on the clustered images. So again, we can see here the images are being displayed as we have given a function called dispclust, and string concatenation is being used, and a part of that we have used the main difference between the second program and third program is these 3 lines. That's it. And that in the 3 lines we are performing k-means clustering, and we're also performing reducing the dimensions of each picture to 100, and that is being done by using Euclidean distance method, square root of Euclidean distance, and the k-means clustering method. There's a big explanation for that. I cannot just explain in a short method, so I'm just briefing it. So again, you can see 7 different images being obtained, figure 8, 1, and 2, and we'll again obtain 6, 7, 5, 6, 6, 7, 3, 4, and other outputs. We'll be again seeing the things to be combined into clusters. And again, here you can see the difference in the workspace, the type of matrices being formed. Here 7 into 4096, because the size is here 64 into 64, which is 4096. For the first solution, as I've shown you, that it was 128 into 128, so it was 16,384. So the size of the array would be increased with the number of pixels. So we are reducing it by performing PCA, because the dimensions of the pixels are reduced to 100. So the size of the array would be decreased, and the efficiency of getting the outputs would also increase, and less amount of data would be used in order to perform get the output. So almost 4 of them are formed, and 2 more. It is taking a lot of time because we have already run the first and second program. So a lot of pressure on the CPU. usually taking a lot different from the other time. It is usually taking more time now. So you can understand whether the output is correct or not just by seeing the command window, because the cluster is being displayed here. As the images are being displayed, it shows that it is being grouped into different images, into different clusters based on based on this org which I've given, and based on the size in sequence of the images. As you can see here, the third cluster would start from this number and would end to the next cluster would be somewhere here. Yeah. So here, so this is a group for some first cluster, or I just can't tell you because I'm not displaying the number of the cluster. I should have done that in the program, so that would be clear. So it would display for this cluster is for first cluster, second cluster, and third cluster, and so on. So yeah, that would be a correction. So that was the main challenge which I was facing in order to understand how to group those images, and then I could figure out I can group it out by using the a sequence of the images, and you can see that there is a no particular connection as in the folder which of face images. So that is the main tricky part of the assignment. And you can see here that we have almost obtained all those figures, and it is just that we'll give one more minute time so that all the figures are being displayed on the output. This kind of so here you can see that figure 2 was also already obtained the images. Into it's just taking time to update the picture because it's a lot of data to be shown in a small amount of time. So these are the 7 different pictures, and with this I conclude all questions practically showing the result. And I would also conclude by saying thanks a lot for the support during the semester, and thank you so much for